Welcome to this explainer. Today, we're diving into something absolutely crucial: the massive, life-giving water networks that literally shape the entire Indian subcontinent. We're talking about a vast, interconnected web that dictates the geography, sustains billions of lives, and holds some incredibly deep cultural significance. Let's get right into it.
Here's how we're going to break it down today. First, we'll decode the drainage system basics. Second, we'll look at the restless Himalayan giants. Third, we'll explore the ancient peninsular network. And finally, we'll tackle the modern water challenge. All right, Section 1, decoding the drainage system. To truly understand a landscape, you first have to understand the exact channels its water travels through. And this brings up a really fascinating geographical mystery. Have you ever stopped to wonder why the vast majority of rivers in India, whether they start way up in the snowy Himalayas or down in the Western Ghats, almost all end up flowing east to discharge into the Bay of Bengal?
Well, to answer that, we have to look at drainage basins. Think of a basin like a giant unified catchment area. It's separated from other basins by a boundary line we call a watershed. Now, what's really crucial to remember here is unity. It's all connected. A change in one tiny part of the basin ripples out and directly affects the entire system.
And the physical rock and slope of the land actually create these distinct, highly visible patterns. It's literally like natural art. You might see tree branch-like patterns called dendritic rivers out in the northern plains. Or you've got radial rivers bursting outward in all directions from a central point, kind of like the Amarkantak Range. Then there are these right-angled trellis patterns and even centripetal systems where water just flows inward from all sides into a single depression. Now, looking at the grand water divide of the country is pretty striking. Natural barriers like the Delhi Ridge, the Aravallis, and the Sahyadris act as these massive, impenetrable walls. Because of the natural eastward tilt of the land, these barriers force a staggering 77% of India's drainage area east to the Bay of Bengal. That leaves a mere 23% to flow west into the Arabian Sea. It's a huge imbalance. Moving right along to Section 2, the restless Himalayan giants. These northern rivers share an absolutely wild geological history. Get this, between 5 and 24 million years ago, there wasn't a network at all. It was just one single massive river known as the Indo-Brahma. Over deep time, huge tectonic upheavals, like the sudden rising of the Delhi Ridge, violently ripped this giant apart into the Indus, Ganga, and Brahmaputra systems we know today, eventually tilting them eastward. Because they're fed by both melting mountain snow and heavy monsoon rains, these volatile rivers are perennial, meaning they literally never run dry. Up in the mountains, they are incredibly powerful, violently carving out these massive, deep V-shaped gorges. But the second they hit the flat plains, their whole personality changes. They suddenly start meandering all over the place, constantly shifting their courses and depositing massive, sprawling deltas. A really perfect, though often tragic, example of this restlessness is the Kosi River. People actually call it the sorrow of Bihar. Why? Because it drags down such enormous quantities of heavy sediment from the mountains that it ends up choking its own channel. So blocked by its own debris, the river suddenly jumps and changes course, triggering massive, unpredictable flooding across the plains. Right at the heart of this northern network is the absolute behemoth that is the Ganges system. It spans over 2,500 kilometers. Starting out as the Bhagirathi, it officially becomes the Ganga at Deoprayag. Its basin covers a mind-boggling 8.6 lakh square kilometers in India alone. And what's super unique about it is that it gathers both those perennial, snow-fed rivers from the north and non-perennial, rain-fed rivers from the southern peninsula. All right, let's head south for Section 3, the ancient peninsular network. The contrast here is just night and day. While the Himalayan drainage is young, wild, and volatile, the peninsular drainage is incredibly ancient and mature. They don't have melting snow, so their flow relies entirely on seasonal monsoon rain. Instead of fiercely carving chaotic, deep gorges, these older rivers flow very predictably through broad, shallow, fixed valleys. They've settled in over millions of years. The sheer scale of these southern giants is amazing. The Godavari definitely stands out at the top. It's the largest peninsular system by far, and it's so massive and culturally significant that it's earned the title Dakshin Ganga, literally the Ganga of the South. Further down the list, you've got the Kaveri, which is a really cool exception because it carries water all year round, thanks to catching rain from 2 different monsoons. But, nature always throws in a few exceptions. Remember that dramatic eastward tilt of the continent we talked about? Well, the Narmada and Tapi rivers completely rebel against it. They flow straight west into the Arabian Sea. They manage this by traveling through deep trough faults, essentially massive cracks created by ancient geological upheavals. So they flow through rocky rift valleys instead of fanning out into typical deltaic deposits.
Which brings us to our final act, Section 4, the Modern Water Challenge. So what does this all mean for us today? The core dilemma is basically one of distribution. India's rivers carry a staggering volume of water every single year, but it's incredibly uneven, both in time and in geography. During the monsoon, immense amounts of water are lost to massive floods. This creates a really bizarre reality where one region is literally underwater, while another region, at the exact same time, is completely crippled by drought.
Now, you might hear people propose linking rivers as the ultimate magic bullet for this, but it presents some absolutely colossal engineering hurdles. It's not just about digging a simple canal. You have to overcome crazy uneven terrain and literally defy gravity to pump water from flat, low-lying plains way up onto high plateaus. And honestly, all of that assumes the northern rivers even maintain a reliable year-round surplus to share in the first place. And beyond the sheer geography of it, these systems are just suffocating under human pressure. We're dumping untreated city sewage and toxic industrial waste straight into the flow. On top of that, human settlements keep encroaching on the riverbanks, literally shrinking the channels. And as water gets scarce during those dry seasons, we're seeing more and more intense, complex disputes breaking out between states over water rights. It's not all doom and gloom, though. There are some major, large-scale interventions happening right now, like the Namami Gange program. This is a big deal because it treats the river as a living, holistic system, rather than just a massive water pipe. It combines aggressive sewage treatment infrastructure with things like tree planting, biodiversity protection, and strict industrial monitoring to try and stop the pollution right at the source. Which leaves us with one final absolutely critical question to consider as you look back at everything we've uncovered. With all these mighty, ancient rivers carving through the subcontinent, is the crisis in India really a problem of water availability? Or are we simply failing to manage the incredibly abundant resources we already have? It's definitely something to think about. Thank you so much for joining me for this explainer, and keep exploring.